Hey guys, so in this video we're going to learn about the quadratic formula. Now let's say that I have the quadratic equation y is equal to ax squared plus bx plus c. So here I have the equation of a parabola. Now let's take a quick look at a sketch for this parabola. Alright, so here we have this parabola that has the equation y is equal to ax squared plus bx plus c. And what I want to do is I want to determine the x-intercepts. I want to determine the values of the x-intercept or the roots for this parabola in terms of a, b, and c. In other words, I want to know the values of x at which this curve intercepts the x-axis or intersects the x-axis in terms of a, b, and c. So what that means over here is that we know that at the x-intercepts, right, y is equal to 0. Y is equal to 0. In other words, that means that we have ax squared plus bx plus c is equal to 0. And I want to solve this equation and get an answer for x. I want to determine the values of the x-intercept in terms of a, b, and c. Now it's actually easier to solve this equation if we were to first convert this quadratic equation into the completed square form. So if we were to convert this into the completed square form, we'd have this equation in the form y is equal to a times x minus h, the whole thing squared, plus k, where obviously the coordinates of the vertex over here are h comma k. So we have the coordinates of the vertex here. And if we were to solve this equation now, in other words, if we say y is equal to 0, we can say over here that we have a times x minus h, the whole thing squared, plus k is equal to 0. So we can say over here that we have a times x minus h, the whole thing squared, is equal to negative k. Okay, and we want to solve for x over here. So what we have is we have x minus h, the whole thing squared, is equal to negative k over a. And then we can say that x minus h is equal to plus or minus the square root of negative k over a. And if we just add h on both sides, we get x is equal to h plus or minus the square root of negative k divided by a. Now, how do we interpret this result over here? Well, first of all, it's important to note that h is simply the x-coordinate of the turning point of this parabola. In other words, the x-coordinate of the vertex of this parabola. So what this is telling me is if I have a parabola like this parabola is clearly, the way I've shown it, is intersecting the x-axis at two different points. And those 2 points are obviously going to be equidistant from the vertex since the parabola is symmetric. So my two x-intercepts over here are h plus the square root of negative k over a. That's this one on the right. And the other one that I have is h minus the square root of negative k over a. But my objective over here is to find the values of the x-intercept in terms of a, b, and c. Now we have learned previously.
Quick pause. If you're finding value in this explanation, there's so much more to discover. At Alt Academy, we break down every A-level concept with the same level of clarity. Now, let's continue.
That if we were to take an expression, if we were to take a quadratic expression in the expanded form ax squared plus bx plus c, and we were to convert it into the completed square form, a times x minus h, the whole thing squared, plus k, the values of the x coordinate and the y coordinate of the vertex, in other words h and k, can be expressed in terms of a, b, and c. You know that h would be equal to negative b over 2a and k would be equal to 4ac minus b squared divided by 4a if this equation was converted into the completed square form. So now that we have the values of the x-intercepts in terms of a, h, and k, we can find them in terms of a, b, and c simply by substituting the expressions that we have for h and for k in terms of a, b, and c. So if we do that over here, if we're solving this equation ax squared plus bx plus c, we can say that the values of the x-intercepts are equal to, we have h plus or minus the square root of negative k over a, and h can simply be written as, that's the x-coordinate of the vertex, can be written as negative b divided by 2a, that's h over here, plus or minus the square root of negative k over a. So over here we have plus or minus the square root of negative k, so that would be negative 4ac minus b squared divided by 4a divided by a. So that would be divided by 4a squared. And if we simplify this expression that we have in the underneath the square root sign, what we get over here is we get x is equal to minus b divided by 2a plus or minus the square root of b squared minus 4ac divided by 2a. Here, negative 4ac minus b squared is simply b squared minus 4ac, and that's under the square root. And square root of 4a squared is simply 2a. And over here, since we have a common denominator 2a, we can take a common denominator here. So we can say that x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And this over here is the quadratic formula. This is known as the quadratic formula. And what the quadratic formula tells us is that if we have any quadratic equation in the expanded form, y is equal to ax squared plus bx plus c, and we want to know the values of x for which y is equal to 0. In other words, we want to determine the x-intercept, so the roots for this equation here. We want to solve this equation here. We can simply express the values of the x-intercepts in terms of a, b, and c, which are the coordinates of x squared, the coordinates of the x term, and the constant term, respectively.
Now that that's taken care of, head over to our website to watch the rest of our A-Levels maths course. With 60,000 students trusting us, visit All Academy now and transform your A-Levels journey.